Hi, I'm Tony from Hub Gaming, and today I'd like to speak to you about making parts spin in Roblox Studio. Have you ever considered that it doesn't look the same on different computers? Your spinning script could be dependent on the refresh rate. It could look smooth on one device yet glitchy on another. In this video, I'm going to break down the different ways you can make a part spin on Roblox Studio, showing you which ones work best and how to do it the right way for a consistent effect no matter what setup you're working with. Before I start, I want to point out I'll be adding the scripts directly into the workspace, and this isn't really a good way to do it. There are better ways, and I've covered that in a previous video. If you want to check it out, you can do so by clicking the link in the description below, or you can click on the card at the top of this video. So today, I've got 6 examples that I want to run through. Each one's slightly different and each one has its own benefits. Once you understand the pros and the cons, you can always pick the right one for you. First one I'm going to bring in uses the run services stepped function. If I press F8 to run it here, you'll see it's spinning perfectly fine. The run service enables developers to hook into the game's frame loop, allowing a frame-based update such as animations and real-time calculations. It fires before each frame simulation step, so this is an ideal option when you want to sync frame-dependent tasks with the game's physics engine. It's also more stable across refresh rates compared to rendered stepped, which is the next one I'm going to show you. So I'm going to stop this, we'll leave this in, and we'll bring in the rendered stepped option. Now what you'll notice with this option is I also have a second script. One's my local script, one's a server script. If we quickly look into the server script, you can see what it's doing is waiting for the player to be added, and once the player is added, it clones the local script into the player GUI. That way I can run the local script and I can store the script that's relevant to this part under this part. Once the script is completed, it then destroys itself. So if we look at the local script, we can see that it uses the run service render script function, and the part C frame is calculated in the exact same way as it's done with render stepped. It's worth pointing out that the only reason these two continue to rotate smoothly is thanks to delta time. If I was to remove delta time from these, and we run our game, do it appear not to spin? If I print the value to the console, we'll see that the run service is still getting called as usual. So we can see down here in the console, if I bring this up here, both render stepped and stepped are being called every time the screen is refreshed. But if we look over here, the parts don't appear to be moving. Now to try and get them to move, I could change the rotation and we'll see that they're starting to move. But the problem with this is, like I said earlier, this run service is frame rate dependent. So I'm running at 60 frames per second, and this is the speed I see it. But if you have someone running at 240 frames per second, it'll be so much faster. For this type of animation, we'd want it the same on every user's computer. This is where delta time comes in. So I'll change these back to 90 and re-add delta time. So by using delta time, the rotation is now scaled by the time that's elapsed since the last frame. Let's get rid of this print statement, press play again, and we'll see that it's a more reasonable speed for what we would expect. I'm going to close this script down now. I'm bringing the last script that's frame rate dependent, and this one is the run service heartbeat. And you can see once again, if I just bring this down the line, that the script inside is the same as what stepped and rendered stepped was, but this uses the heartbeat function which fires after a physics simulation for each frame. So just to recap, stepped fires before each physics simulation, rendered step fires before the frame is rendered, and heartbeat fires after each physics simulation of the frame. So if I come back to here and press play, we'll see now that all three are spinning. It is worth noting that stepped is only available on the server, rendered stepped is only available on the client, and heartbeat is available on both. So I'll close these three down now, and let's take a look at the frame rate independent options. These are for spinning mechanics that don't depend on the game's frame rate. These are more suitable for the example that I'm using here. The methods that I'm going to go over either use a fixed time step or a physics-based calculation ensuring a consistent performance across all devices regardless of the refresh rate. So if we start off with the tween service, drop this in, press play. Now if I show you what's going on in here, We're setting up our tween info, setting the spin to run forever, and saying that we don't want to reverse it once it gets to the end, so this will be a consistent spin the same way. We then get its initial orientation and say the goal is whatever the initial orientation position was, plus another 360 degrees, so it goes for a full loop. We then create our tween and we play it. Now this one doesn't depend on how often a frame refreshes. Instead, it calculates the values over a specified period of time, which means this green one would be the same on every user's computer. Our next option to make something spin is with the body gyro. We'll look at the script first. And here I create a new body gyro, set the body gyro C frame to be the parts C frame, set the max torque, which is the amount of force that it can exert across the Y axis, then set the power it needs to use to maintain the desired orientation. The higher this number is, the faster it'll rotate. This is our body gyro example. If you look at the other examples, you'll see that they're all anchored. But the body gyro can't be anchored. If I anchor it and press play, we'll see that it can't move. And that's due to the fact that the body gyro calculations are physics based. And when you anchor a part, the Roblox physics engine ignores forces applied to that part. So for this one to work, I need to unanchor it, but then it'll have a slightly different effect. So it's going to drop to the floor and try to walk off. Whenever you're using anything that puts more demand on the physics engine, you're adding more load to the game. There are times when this could be useful, but for the sake of making the box spin, this is definitely not the option you want to go with. And the last one I want to show you is the while loop. Once again, this is time-based and not frame rate dependent, so it ensures consistent behavior in different refresh rates. So if I run this one, our body gyro is walking off again, but we've got two frame rate independent blocks that'll spin consistently on different setups. So while the run service can be used for animations, it's probably not best to do it because you're tying your animation to a frame rate. There are times when that's useful, but for this example that we're looking at today, it would not be the one that we want to use. The tween service or a while loop would be ideal for these scenarios. So here now we've got 6 different options which you can choose from. The first 3 are a great choice if you want something that's frame rate dependent, or tween service and while loop are ideal if you want something spinning that's frame rate independent, and the body gyro is ideal if you want something that spins and is dependent on the Roblox physics engine. And that's everything from me for today. If you have any thoughts, please drop a comment in the messages down below, and I'll see you in the next one.